This is Algebra 2, Unit 11, Lesson 6, on basic graphs of sine and cosine. Now, the sine and cosine functions can be easily graphed by considering their values at the quadrantal angles. Quadrantal means quadrant angles, the ones that are multiples of 90 degrees or pi over 2 radians. Now, due to considerations of physics and calculus, most trigonometric graphing is done with the input angle in units of radians, not degrees. So when you see these, you usually see them as radians. Okay, so we are going to graph f of x equals sine x and g of x equals cosine x, where x is an angle in radians. Okay, so use the unit circle, fill out the table of values for select quadrantal angles. All right, so we know this is 0 degrees. Let's remind ourselves what the values of the quadrantal angles are. All right, pi over 2 would be 90 degrees. Pi would be 180. 3 pi over 2 would be 270, and 2 pi would be 360 degrees. Okay, and going backwards, negative pi over 2 would be negative 90, negative 180, negative 270, and negative 360. Okay, so let's take a look at our unit circle. Remember, cosine is the x-coordinate, sine is the y-coordinate. So here's our unit circle diagram. All right, so starting at 0 for the x's, it would be for cosine, it would be 1. And then we would go to 0, and then negative 1, and then back to 0. All right, so 1, 0, negative 1, 0, and then 1. Okay, and then going backwards, negative 90 would be 0, negative 1, 0, and then back to 1. So we're moving backwards here, so this would be 0, negative 1, 0, and then 1. Okay, so those would be the values of cosine. So if I graph cosine on my grid and label it the curve, we'll go see what it looks like. All right, so we said for cosine, let me do it in red so we can see it. We started at 1 at 0, then it went to 0, and then negative 1, 0, and then back to 1. And then negative pi over 2 just reverses the process. So this goes to 0, negative 1, 0, and then back to 1. So if you can remember what cosine is, it looks something like this. It starts at 1 and just repeats the process. So this is y equals cosine x. Okay, now let's take a look at sine. If I look at my sine function, I'll go back to here. Okay, my values for sine. Remember, the sine is the y-coordinate. Cosine is x, sine is y. All right, if I look at my unit circle diagram, at 0, it's going to be 0, and then at 90 would be 1, 0, negative 1, and then 0. So filling in my values, I start at 0, I go to 1, back to 0, negative 1, and then back to 0. Okay, and then if I reverse the process, I'm going, remember negative 90 is equivalent to 270, so this is going to be negative 1, 0, 1, 0. Okay, so working through my values here, when I graph these, here's my other graph. Let me do this in blue so we can see the different one. Okay, now sine starts at 0. It goes to 1 at 90 degrees, or pi over 2, then back to 0, negative 1, and then 0, and then it reverses, negative 1, 0, 1, and then back to 0. So drawing my graph, it looks like this. Okay, so if you can remember your facts for this, sine starts at 0, cosine starts at 1. All right, and it just goes in a pattern. 0, 1, 0, negative 1, 0 for sine, 1, 0, negative 1, 0, back to 1 for cosine. Okay, the domain and range of the sine and cosine functions are the same. State them below in interval notation. Okay, now the domain is the x values. Now, even though it's in radian mode, we can see on here, this is just going to keep going in the same pattern, isn't it? So it's going to be any real number for the domain, because this can keep going out as far as you want. This goes from negative 2 pi to positive 2 pi, but it can keep going the same pattern. So your domain for that will be from any real number. So negative infinity to positive infinity. So domain is going to be from negative infinity to positive infinity, which means any real number. Okay, the range is going to be your y values. So if we take a look at our y values on our graph, here's my y values. Where do the y values fall? The highest and lowest y values. Well, they go from negative 1 would be the lowest to positive 1 to the highest. So our range in interval notation will be from positive 1 to negative 1 inclusive. So your range will be from negative 1 to positive 1 inclusive. All right, letter D. After how much horizontal distance will both sine and cosine repeat its basic pattern? This is called the period of the trigonometric graph. Because these periods have patterns that repeat, they are called periodic. Okay, so let's look at this graph. All right, so we start here, let's start at 0. For sine, it goes from 0 to 1 to 0 to negative 1, then back to 0, and then it's going to start repeating again. So the period of this graph is going to be from 0 to 2 pi, so it's 2 pi is one complete revolution. All right, same thing with cosine. It starts at 1, 0, negative 1, 0, and then back to 1. Both of these have a period of 2 pi. You get one complete revolution of the sine graph and the cosine graph over a section of 2 pi. Okay, now we would like to explore the effect of changing the coefficient of the trig function. In essence, we're going to look at the graphs of the functions y equals a sine of x and y equals a cosine of x. So basically what we're doing is we are adding a coefficient out front. So we have some examples here of positive, a negative, a fraction, and a value. So let's take a look at the cosine graph. All right, now notice here, y equals cosine x. We're going to use the graphing calculator to sketch and label each of the following equations. Be sure your calculator is in radian mode. Now notice on here that this says radian mode because these values are in radians. Okay, so to put your calculator in radian mode, the first thing you do is you press the mode key. And then the fourth line down right here, see it's in degree mode? You want to arrow down here, press enter, and put it in radian mode. Now when you do that, notice when you go back to your screen, it says radian up here. So when you're graphing trig functions, it should always be in radian mode. Okay, so our first graph, we have y equals 3 cosine x. We have the original y equals cosine x graph here, so let me put that in my calculator so we can compare it. All right, I'm going to put it in the black one down here because that's what's on the screen. All right, so y is equal to cosine of x. All right, so when I graph that, it looks like what's on the paper. Okay, let me do this, show you the window. All right, this is from negative 10 to 10, but I want this to be in radians. So when I graph this, I'm going to press zoom and then 7, which is trig, and then it automatically goes to trig mode. All right, so basically it's going to approximate your values here for your x's and y's. Okay, so when you do the radian mode and press zoom trig, it can do it that way. You can also set your window, if you'd rather, to make it look like what's on there, from negative 2 pi to 2 pi. And then the scale is going to be pi over 2. Because each of the values is going from pi over 2. And then the y is going to go from, let's leave it as, on the paper we have 4, so negative 4 to positive 4. And when we graph this, now that looks exactly like what's on my paper. Okay, so if you press zoom trig, that'll fit it to the graph so that you can see it. But if you want to make it look like your paper, you want to set it to the same values. Okay, so let's try the values. Y equals 3 cosine x. Let's put that in. Y equals 3 cos x. All right, so let's take a look and see what that does. All right, so remember the pattern for cosine is 1, 0, -1, 0, 1. What happened to this? Well, instead of 1, this is going to be 1, 2, 3. And then back to 0, -3, 0, and then up to 3. Okay, so if I graph this, y equals 3 cosine x, I'll even do it in blue so you can see it. All right, there's my graph. All right, and we do it in blue. I'm starting at, instead of starting at 1, I'm starting at 3, 2, 3, 0, 1, 2, 3, 0, and then back to 3, and then in reverse it, 0, 1, 2, 3, 0, and then back to 3. So my graph would look like, look like this. And I draw my curves neatly. Okay, so it's the same graph. We have just made it bigger. Okay, so this is y equals 3 cosine x. Okay, so we have increased basically what's called the amplitude of the graph. All right, y equals -4 cosine x. Now, this is going to make the graph bigger again. What do you think the negative is going to do? Let's see if we remember. Y equals -4 cosine of x. All right, let's graph that on the red one. Okay, so let's see what that did. Instead of 0 or 1 here, this is going to be at 1, 2, 3, 4. So not only did it stretch it, it also flipped it. Remember, when you negate something, it does a reflection over the x-axis. So that graph is going to be, start at -4, 1, 2, 3, 4, and then back to 0, and then up to 1, 2, 3, 4, back to 0, and back to here. So you have the curve will not only increase its amplitude, it's also going to flip it over the x-axis. So your graph of y equals -4 cosine x will look like this. All right, so this is the red one, y equals -4 cosine of x. All right, y equals 3/2 cosine x. Let's see what that does. I'm going to go down here. All right, so 3/2 cosine x. All right, so that's going to, 3/2 is 1.5, so that should increase the amplitude by 1.5. Let's see if it does. Yep, instead of 1, I'm at 1.5, so it's the same graph, just at 1.5. Let me do this in purple so you can see it. 1.5 here, back to 0, -1.5, back to 0, and then back to 1.5, and reverse it. 0, -1.5, 0, and then back to 1.5. All right, so same graph, it's just going to change the amplitude a little bit. There's your curve. So this is y equals 3/2 cosine x. Okay, and then -2 cosine x, what do you think that's going to do? Well, it should increase the amplitude to 2, but then also flip it over the x-axis. So it's going to look like the red graph, except at 2 instead of 4. So let's see if it does. Y equals, I'll go down to the green one, -2 cosine x, and graph it. Let's see. Yep, there it is. It looks like the black graph, or the red graph, except it's going down to the green. So I'll go to my graph here, do it in green. Instead of 1, I'm going to start at -2, 0, +2, 0, and then back to 2, and then back up here. I'm going to go in reverse, and there is your graph. So there is y equals -2 cosine x. So we can see the effect of changing the leading coefficient. It will increase what's called the amplitude, and also do reflection over the x-axis. All right, so as we can see, this coefficient controls the height that the cosine curves work, or rises and falls above the x-axis. Its absolute value is given the name amplitude. So that's the amplitude.